welcome to the first lesson in our semester. We're going to be covering lessons 1 and 2 in your textbook. Because these are pretty simple lessons at the beginning, we're going to try and merge a few things together to speed right through. If you do have any questions about anything you're learning, you can review the textbook, and sometimes reading the textbook, getting some other explanations for what's happening is pretty useful, but sometimes it's nice to just hear it from an actual person instead of reading it. So it's up to you if you want to also use the textbook. You're welcome to it any time in the semester. Alright, so starting out with lessons 1 and 2, we're just going to be talking about the names of numbers. A lot of numbers have very specific names depending on what type of number they are, and these numbers can be helpful in some very specific but also more areas than you might think. For example, if you wanted to play a really serious game of guess a number between 1 and 10, and you didn't want anyone cheating and being like 4.5, you're just like, I want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are the only options. Then you would need to specify exactly which type of number people were allowed to guess, because sometimes people like to be like, oh, well, if it's the closest number, then I'm going to guess like 5.7, because then I'll be all the 5s, but I won't be 6, you know? So if you want to avoid that, you might need to know the name of some of the numbers, and I'll show you that in a little bit. Some of the other numbers are useful in music. You can use some of these numbers, and composers need to know these numbers so that they can figure out how many beats in a measure, how many notes they can fit, that sort of thing. It's also very useful, and the most likely place you'd find some of this information is in places like statistics. If you go into studying psychology or even social work, therapy, there's another of the family sciences that would probably require a statistics course. You might see this in economics, you might see this in business management, you might see this in some IT and software developing. So it will come back, and knowing these numbers, names of numbers, can be very helpful. It's also pretty simple, so don't be too scared. But I just wanted you to know where you might see it and why it could be important in the future. Alright, so jumping into our lesson, let us start at let's start at the bottom. Alright, so the base numbers that you would need to know, and I'll put it down here at the bottom because it's like the lowest level. It includes the fewest numbers, is natural numbers. And natural numbers is a group of numbers that includes only positive whole numbers without 0. I'll type out what that means. That means that natural numbers include 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and on to infinity, but you will never see 0. Let me type this out. No 0. No decimals. You can't have 4.5. No fractions. Okay? So those are the rules for a natural number. And the reason they're called natural numbers, who knows exactly, but the textbook says a useful way to remember this. Natural numbers are the numbers that you would naturally teach a young child as their first numbers. You wouldn't teach a young child a decimal. You wouldn't teach them a fraction. Oh, another no that's on there. No negatives. You wouldn't teach them negative numbers. You would just say, hey, we're going to learn to count. And you start with 1, 2, 3, 4, and so on. So natural numbers are those numbers that you would start with a young child. Whole numbers, no 0, no decimal, no fraction, no negatives. Okay, so that's our base level, basic understanding of numbers. But we know that there are more numbers in this world than just natural numbers. So let's explore some more. Above natural numbers, we have what are known as whole numbers. Okay. Alright, and whole numbers, as you might guess, would also not include no fractions. Hold on, I'm going to check on something. Yeah. Alright, no fractions, no decimals, because any fraction or decimal is like a fractured or not whole number, and no negatives. Okay, so that's the rules for whole numbers. So for a whole number, you would count 0, 1, 2, 3, 4, and so on. 0 counts as a whole number. He's special like that. All right, so that's whole numbers, pretty much the same as natural numbers, but in this case we get to add in 0. All right, then we're going to go on. Here, we'll put this in a category like that. We'll try to put it in a category like that. 1 second. Come on, there. Perfect. Okay, so if you're doing whole numbers, then in your super intense game of guess a number, then it could be like a whole number between 0 and 10, right? And that way nobody could use a decimal or a fraction. It'll get tricky like that. All right, the next level of number is your integer. Integer. He doesn't need to be that big. Okay. In your integer, the textbook has a way that they say to remember it, and because it might come up on one of your tests or your homework assignment, I just want you to be aware of it. So their way of remembering this is to say that an integer includes the negative numbers and 0. Sorry, 0 doesn't come in. All right, so I tried to capitalize the numbers that were the letters that were super important in this. In their little phrase, you can see that includes goes to the IN in integer. The gives us the T. Negative numbers gives us the E and G, and then the last bit of ERS gives us the ER. Right there. So includes the negative numbers and 0. So when we're writing this out, we can be like, this would also include any negative number, -3, -3, -2, -1, 0, 1, 2, 3, and so on. All of those numbers. Okay, so that's an integer. Negative numbers, 0, and positive numbers. But there are still no decimals and no fractions. We like integers because nobody likes decimals and fractions, right? All right, so that's an integer. And I'm going to put it in a box. Boom. Ta-da! All right. I'm running out of space, but we do have a few more numbers to cover. So next we're going to go with, I'm going to move this up and move this down. Perfect. All right, so our next level of number is a rational number. All right, so a rational number includes any number that can be written as a fraction. So yes, fractions. Yes, decimals. And anything that makes sense. So 0 makes sense. We understand what 0 is. Positive numbers. Positive. I can't spell positive today. And negative numbers. So all of your traditional numbers that you would typically think of, it includes all of those. That's a rational number. And as you can see from our little box diagram, rational numbers basically include everything below. Rational numbers include integers, whole numbers, natural numbers, and then they also do the fractions and the decimals. Which is pretty handy. All right, but then we also have, if we have a rational number, then you guessed it, we have to have an irrational number. And you're like, how can a number be irrational? And it's basically because irrational numbers don't totally make sense. They cannot be written as a fraction. So here's a rule. Cannot be written as a fraction. And this is because they never end, never repeat, and so they're basically just never-ending decimal numbers. So your examples of such numbers would be things like pi. I don't know how to write pi on a keyboard, so pi is the number that looks like this and helps us solve circle problems. And then another number that would be considered an irrational number is let's do it this way, the square root of 2. If you were to type square root of 2 into a calculator and ask it what that was, it would give you an exceedingly long decimal number that would run off of your calculator screen and would continue into infinity. The square root of 2 never ends. And pi, which equates to approximately 3.1415 but continues on forever, also never ends, never repeats, and so it can't be written as a fraction, and therefore is an irrational number. Okay, but all of these numbers that we see here are, considered real numbers. Let me put them in a box. Real numbers. Oh, my box died. Come on, box. Real numbers. Alright, so everything we've discussed today is considered a real number. So it rules over all of these. Now, once again, you could be like, okay, so kind of what's the point of knowing this? Well, the point is that in certain areas of life and math, you're going to need different numbers. And when you're working in math a little bit more, you kind of have to specify which type of number are you working with. In statistics especially, the integer becomes very important because there are certain types of studies that can only be conducted with integers, and there are other types of studies that can only be conducted with rational numbers. And then sometimes you might even run into a study that basically only works with natural numbers, which you might imagine isn't super useful, but sometimes that's the case. So in statistics, it becomes very important. As I mentioned, you could use this in economics, you could use this in business. There are just some areas where specific mathematical problems, you have to be really specific about which type of number you're using and why you are using that type of number. So it's very important to know it as base knowledge so that then you can continue on in math without having to worry about using the wrong numbers or using the numbers incorrectly. When you are doing your homework, you're basically just going to be asked to identify which numbers are which, and you can use this chart to help you if you want to. I think it's very useful to see that real numbers includes all of these, and then rational numbers includes all of these, and it kind of works this way down. And so you're welcome to use this chart as you're completing your homework. Your homework assignment for this class, due next class period, is going to be just the odd numbered problems of worksheet 1 and the odd numbered problems of worksheet 2. And that should be everything for today. I will see you in the next class.